In example 5, we are going to learn how to graph logarithmic functions by hand, okay? And the way to do this is to use the fact that y equals log base a of x and y equals a to the x are inverse functions, okay? So let's take a look at this, okay? In example 5, we are going to sketch the graph of the following functions, and then we're going to fill in the blanks for the various characteristics of each graph. Okay, so let me show you what we're going to graph first of all. Okay, so in part A, we're going to try to graph y equals log base 2 of x. Okay, and then after that, in part B, we're going to look at log base 2 of x plus 3, which is just a transformation of the graph in part A. Okay, and then in part C, grab that paper, we're going to try to graph log base 2 of x plus 3 minus 1, which is another transformation. Okay, so the key here is getting the log base 2 graph, and then after we have that, we can just apply one or more transformations as necessary. Okay, so this is how we do this. It's not that bad. Okay, we're going to try to graph log base 2 of x, and what we need to know to do this is that its inverse function is the exponential function 2 to the x. So we're going to go back and we're going to look at 2 to the x, which we did back in section 6.3. Okay, so remember what we did. If you don't remember what 2 to the x looks like, we're going to go back over it. We made a table of values, okay, for 2 to the x, okay. And if you remember, we used x equals 0, we used x equals 1, 2, 3, and then -1 and -2 should be fine, okay? So we plugged each of these in to get a point, okay? So let's see, if we did 2 to the 0, that's going to give us 1. So 2 to the x goes through 0, 1, okay? These are points on the graph of 2 to the x, okay? We're not doing the log function just yet, okay? All right, so plug in 1, 2 to the first power is 2. So we've got the point 1, 2. And then 2 squared is 4. So we have 2, 4. And then 2 cubed, 2 times 2 times 2 is 8. So the exponential graph goes through 3, 8. Okay. All right, and then 2 to the -1 is going to be 1/2. And so our exponential graph will go through -1, 1/2. And then finally 2 to the -2, that's 1 over 2 squared. That's going to be 1/4. So our final point will be -2, 1/4. Okay, so this is going to be the point on the exponential graph. Okay, it is, you know, you can plot this, but this is not the graph that we're after. Okay, we are after the graph of log base 2 of x, and so what you need to keep in mind is that 2 to the x and log base 2 of x are inverse functions. So remember, how do you graph an inverse function? You switch x and y. So I'm going to come over here, okay, and I am going to list out the points on the graph of log base 2 of x, okay? So log base 2 of x will go through the following points, okay? Instead of -2, 1/4, it's going to go through 1/4, -2. Okay, and then instead of -1, 1/2, it will go through 1/2, -1. Okay, and I'm just going to switch the x and y coordinates here to get points on the graph of log base 2 of x. Okay, so we're going to have 1, 0, we're going to have 2, 1, 2, 4, or sorry, 4, 2, and then finally 8, 3. Okay, so we can go ahead and plot these points and see what this graph looks like. Okay, all right, so on this first point, 1/4, -2. Okay, so the x-coordinate's 1/4, so that's like 0.25. So you're going to have to eyeball it. Let's say this point is about right here. Okay, and then 1/2 is 0.5, -1, and about right there. And then we've got 1, 0. We've got 2, 1, 4, 2, and then 8, 3. Okay, so you can kind of see the shape that the logarithmic graph is taking. Okay, if we connect these dots, this is what this side is doing. Okay, and what's going to happen in this direction is we're going to get closer and closer to the y-axis, but never touch it. So this is going to be a vertical asymptote. That's what the y-axis is. Okay. So you can kind of think back to what an exponential function looks like. So if you think back to the graph of 2 to the x, you can think about how the logarithmic graph compares to the exponential. If you remember, if we graph 2 to the x, exponentials, one side climbs very quickly, and then the other side leveled off somewhere and had a horizontal asymptote. Okay, so in contrast, what the logarithmic graph is going to do, it is climbing, but very slowly. Okay, this is a very slow climb. And then the other side is leveling off somewhere, and you're going to have a vertical asymptote. Okay. All right, so this is the graph of part A. So this one is log base 2 of x. Okay, and again, we didn't have to actually graph 2 to the x to get that. We just needed a list of xy pairs, and then we had to switch the xy pairs on 2 to the x to get the ordered pairs for log base 2 of x. Okay, and this is how it's going to work. So like, you know, if you were trying to graph log base 3 of x, you would start with the appropriate exponential function. You would start with 3 to the x, get points on that graph, and then switch x and y to get the points on the graph of log base 3 of x, and so on. Okay. All right, so now that we have our log graph, okay, we're going to go ahead and list the attributes of the graph. Okay, so first of all, the domain. Okay, so you're going to go from your leftmost point to your rightmost point and write down x values. Okay, this graph gets closer and closer to the y-axis, but never touches it. Okay, so essentially, you know, your x values are going like 0.5, 0.25, 0.1, 0.01, 0.00001. You're getting closer and closer to an x value of 0, but not actually getting there. So essentially, we start at 0, but we don't actually get there, so we're going to exclude it. Okay, so, and then our rightmost point is going to be positive and infinity. So the domain is from 0 to infinity, not including 0. Okay, the range. Okay, the lowest point on the graph is negative infinity. Okay, and remember what I told you. This graph is climbing. It is very slow. Eventually, it will climb up to positive infinity. It's going to take forever, but eventually it will get there. So the high point will be positive infinity. Okay, so the range is all real numbers. Okay, the x-intercept. Okay, well, this graph, the x-intercept is right here at 1, 0. So you can either write x equals 1, or you can give me the ordered pair 1, 0. Okay, the vertical asymptote. Okay, that's that vertical line that our graph gets closer and closer to, but never touches or crosses, and that is going to be the y-axis. Remember, when you're dealing with asymptotes, you have to actually give me an equation. Okay, so I'm going to write so far for the vertical asymptote, we know it's the y-axis, which is the equation. So remember, if you're thinking vertical line, think back to how you write down the equation of a vertical line. It's going to be x equals, okay? And for the y-axis, it's going to be x equals 0, because if you look at the y-axis, every point on the y-axis has an x-coordinate of 0, okay? So that is the equation for the vertical asymptote, okay? All right, so now we are going to look at the graph in part B, which is log base 2 of x plus 3. Okay, so if you notice, this graph also involves log base 2. Okay, so all that is changed is that instead of x, we have x plus 3 in parentheses. Okay, so hopefully you recognize this as a transformation. Your parent function is going to be log base 2 of x, which we have already graphed. Okay, so now we have x plus 3 in parentheses. Okay, so since you're adding inside parentheses, this is a horizontal shift. We're taking the graph of log base 2 of x, and we're shifting it 3 units since we're adding, we're going to the left. Okay, so that's all we have to do here is take our parent function, which we graphed up here, and shift it 3 units to the left since we're adding. Okay, so let's go ahead and do that. Okay, think back to when we did this with exponential functions. I told you, you need to think about moving the asymptote first because it will give you a boundary line. So remember, you know, I didn't really draw it in here, but I mean, I could have. For this parent function, this is our parent function, the vertical asymptote was right here. It was the y-axis. So if you wanted to, you could have put a vertical line there dotted to represent the asymptote. Okay. If we are shifting left, that asymptote is going to move as well. It is going to move 3 units to the left. Okay, so I'm going to go ahead and move my asymptote first so it gives us a boundary point. Okay, so I'm going to move 1, 2, 3 units to the left. And I'm going to go ahead and put this graph in pink. Okay, so here's going to be my vertical asymptote for this new graph. Okay. All right, so now I'm just going to take each point on the blue graph and shift it 3 units to the left. Okay, I'm going to start with the easy points here. So this is 1, 0. It's going to go 3 units to the left. So 1, 2, 3. It's going to end up at -2, 0. Okay, and then I'm going to move this guy 1, 2, 3. So we end up at -1, 1. 1, 2, 3. We end up at 1, 2. And then 1, 2, 3, we end up at 5, 3. Okay, these guys you're going to have to kind of eyeball 1, 2, 3. And then 1, 2, 3. All right, so that's what your graph should look like. Okay, your points. You're going to connect the dots. You're going to have the same basic shape as the original graph. Okay, so you're going to have a slow climb in this direction, and then this side will get closer and closer to the vertical asymptote. Okay, so this graph is going to be log base 2 of x plus 3. Okay, so that's what it looks like. Okay, and now we can go ahead and write down its attributes. Okay, all right, so let's see here. First one is going to be, we're going to have to look at domain and range. Okay, so let's take a look at that. Okay, so domain, okay, we need to go from left to right. Okay, again, if you look at these points right here, your x values are getting closer and closer to -3. Okay, but because of that vertical asymptote, we're not actually reaching an x value of -3. Okay, so you're getting to x values like -2.5, -2.75, and so on. So your x values are getting closer and closer to -3, but we don't actually get there. So our leftmost point, we're going to go ahead and consider it an x value of -3, but since we don't get there, we're not going to include the -3. Okay, the rightmost point, okay, we go off to positive infinity. Okay, so your domain is going to be from -3 to positive infinity. Okay, the range, okay, the lowest point is going to be -infinity. The highest point, again, this is a slow climb. Eventually, the highest point will be a y value of, well, it will correspond to a y value of positive infinity. So your range is going to be all real numbers. Okay. Hopefully you'll start to notice this. If you remember, if you were dealing with an exponential function, the domain was always all real numbers. And since, you know, exponentials and logarithms are inverses of each other, what you'll see is that the range of a logarithmic function will always be all real numbers. Okay. All right, for this graph, the x-intercept has definitely changed from the parent function. Now our x-intercept is right here at -2, 0. Go ahead and write that in. So again, I'm going to write x equals -2, or the ordered pair -2, 0. And then lastly, we need to write down the equation of our vertical asymptote. Again, since it's a vertical line, it's going to be x equals, okay? And if you look at this pink dotted line, every point on this pink dotted line has an x coordinate of -3, okay? If you looked at various points on that line. So the equation of the vertical asymptote is going to be x equals -3. Okay? All right. Lastly, we're going to take a look at part C. Okay. which is just one more transformation. Okay. All right, so I'll kind of do this, kind of cover this up here so we can keep the graph right here. All right, so part C, it's log base 2 of x plus 3 minus 1. So if you notice, if I cover up this minus 1, this is the pink graph we just did, okay? So now I'm taking that and I'm subtracting 1, and that's not in parentheses. So this minus 1 is going to now take our pink graph and shift it down 1 unit, okay? So I'm going to write here, and I'm going to put this graph, I guess, in green, okay? So this is, we're going to take the graph of log base 2 of x plus 3, which is the pink graph, and shift down 1 unit. Okay, so that's what we're going to do here. Okay, so I'm going to go back to my graph. Okay, again, the pink graph is log base 2 of x plus 3, but now that 1 on the outside is going to cause us to do a shift down. Okay, again, you want to consider moving the asymptote first. Okay, so if you shift all these points down 1 unit, that is not going to impact the vertical asymptote. It's going to stay put. Okay, so that's not going to move. So we'll go ahead and take each of our points and move them down 1 unit. Okay, so we'll get these green points right here. All right, and then again, these little guys you're just going to have to eyeball over here. Okay, so you're going to end up with this green graph that looks like this. They kind of, oops. This should be getting closer and closer to the pink graph, or the pink dotted line. All right. Okay, so that's what this looks like. Okay, you just shifted the whole thing down 1 unit. Okay. All right, so let me go ahead and write this in. This green one is log, I'll go ahead and do this. This is log base 2 of x plus 3 minus 1. Okay. All right, so lastly for attributes, okay, so what has changed from the pink graph? Well, the domain has remained the same. If you look at the green graph, the x values are still getting closer and closer to -3. But we never cross or touch the pink dotted line, okay? So the domain is going to remain the same, okay, as the pink graph. Okay, so the domain will be from -3 to positive infinity, okay? The range is still all real numbers because our low point goes down to negative infinity and our high point goes to positive infinity, okay? The x-intercept has definitely changed, okay? So now it's right here, okay, at -1, 0, okay? So I'm going to go ahead and write that in. My x-intercept is at x equals -1 or the point -1, 0, okay? And again, like we said, the vertical asymptote, taking that pink vertical asymptote and shifting down 1 unit does not impact the vertical asymptote. So the equation stays the same. Okay, it's going to be the same thing it was for the pink graph. Okay, so basically the green graph, all the attributes remain the same with the exception of the x-intercept. Okay, so last thing I'll write in at this point is going to be that the vertical asymptote is still x equals -3. Okay, and that is basically how you graph a logarithmic function. Okay, again, just to recap, you are going to start with the corresponding exponential function of the same base, and then switch x and y to get the simple logarithmic function. One side for the logarithm will climb very slowly. The other side will level off towards a vertical asymptote, and then you can apply one or more transformations if asked to do so.